Hi, this is Andrew Bunnell, and today we're going to be looking at the physical pendulum. Here I have the physical pendulum running right now, and I have the fraction, or the rod, slightly higher, so the pivot point is at that location. It's at 0.11. I also changed the mass of my rod, and here's a set of table data, Control A, Control C, and I'm going to paste that into my Excel spreadsheet right here under B23. Now this spreadsheet looks a lot more complicated than the previous spreadsheet you've been using. It has all these matrices over here. It has this thing called a weighted Jacobian. You don't really need to worry about any of that. This spreadsheet will do its work for you. The first thing after you copy your data in and change the names, you also copy down the uncertainty. We don't exactly know what the uncertainty is yet, and we also go down to see that there's one X, one Y, one Z, like we've done. There might be a little, shift end up, a little error in the data. Notice how it says 01, 01, 01. So to delete that, I'm going to just highlight these rows right here and delete, and then shift cells up. Okay. Now from this chart right here, from this graph, you're going to have to estimate different parameters. You're going to have to estimate A, T, C, and B. And really quick, the B for the shift up and down, it looks like it goes around 0, so I'm going to include that with 0. And C is how far this first peak is, and I think that first peak pretty much starts at the peak, because that's kind of what the applet did. So I'm going to say that starts at 0 as well. Now for A and T, for the period, I would go from peak to peak, and I estimate 0.16. I could just hover that mouse over there. Oop, it's not hovering to give me a value. Let's try clicking there. 0.164. 1.64. And then the peak amplitude, I'm going to say 0.22. I'm going to come over here and press the reset buttons. I'm going to look to see if I did a good job, and I could have changed the period just a little bit, but I'm going to go ahead with that and see if I hit the iterate fit button 10 times, if my data and my residuals look pretty much random, if that lines up. And it does. When you do have a good fit, don't forget to copy the standard deviation of the residuals, Control C, value paste it as your uncertainty, Control V, right click to copy it down, and then you record the fit parameters in this yellow box. Here's the fit parameters for A, T, C, and B, and here's the standard error for each of those. And then there's a question about comparing the period to the model prediction using the inertia of the pendulum that you chose. When you've completed that, you're going to copy your time and position data to the next sheet. I've already done that here, and I could value paste it again. Don't forget your headers, and now we need formulas for omega and alpha. Well, omega is just simply the derivative, or the delta function, of 1 after of minus 1 before the position divided by 1 after minus 1 before of the time. And then omega is, let me move that out of the way, omega is the same thing, 1 after minus 1 before divided by 1 after minus 1 before. Don't forget, at the bottom, you're going to have to delete those extra rows, 1 for angular velocity and 2 for angular acceleration. Now, I've already created a graph, but to create a graph, you just select these rows and then do insert and click on the dots right there. Don't forget to add in titles and chart titles. Let me just click on the chart. You're going to click on design, add chart element, and we're going to add in the chart titles. Don't forget to make the points smaller. To do that, you double click on the points, click the paint can, marker options, and make sure you choose built-in and then 2, and you can just select the next one and do the same. Some extra information that might be good to have, maybe a good annotation, is the mass that you used for your pendulum and the fraction above the pivot. Now this table right here isn't talked about in the writing. However, I created this table because of I it shows the relationship between angular position, angular velocity, and angular acceleration. If you looked at the formulas at the top of this section for omega and alpha, there's a similarity between the formulas. And so the similarity is just by multiplying by an extra omega. And so here I have the first one multiplied by an omega, and that's from my fit, and I get a value such as that. Now, to get the actual value from the graph, I'm going to zoom way in. Let's see, I'm going to zoom way in on the graph, and I'm just going to hover that point. And right now I'm seeing 1.04, and there I got 0.8. Oh, this is tricky to do when I'm using a small screen. Previously, when I did it, I got the data 0.08, which compares quite a bit to that value. Now for alpha, I'm going to do it by omega squared, and remember omega is 2 pi divided by your period squared. And so there, and to get this value right here, you just kind of hover over the middle of that. And this time I saw a point that's 3.2, and previously I saw a value that was 3.36. For the final section of torque, we're going to add some more columns and then do a quick comparison. So let me set it up and I'll be right back. So I've added in a couple columns, and I've shifted things over just a little bit. I've added a column for MGD5, and if you notice I have to put in a little thing before the negative or else it thinks it's a formula. And here's a column for I alpha. I also put in a couple columns for mass and D. And if you remember, D is that A minus the center. And so for mine, I had a pivot of 0.011. And so I take half of the length, which is 0.5 minus 0.11, and I get 0.039. My mass was read from the applet. And here's the formula from the discussion from inertia. We take 1/12 times our mass, and then we times it by the length of the bar squared, and the length of the bar is 1, plus mass times d squared. And so there's my value. There's my value for inertia. Now MGD5, I'm using my position data, and I'm also using my mass and d. But to keep those from moving, I have to add in those dollar signs. One way I could do it is I could just press F4, F4, F4. So if it was like that, press F4 one time, it'll shift to that. Same thing with H. And that will keep that fixed to that cell. And then I'm going to copy that down. Over here, I do the same thing where now it's I times alpha, and I have dollar signs around the I and the 3, or before the I and the 3, to keep it referenced to that cell. When I do that, then I would highlight those two columns, go to Insert, insert this chart. I've already done that, as you can see down below. Don't forget to add in the chart elements. So you do that by going to Design, Add Chart Element, Axis Titles, turn both of those on. And we're also going to add a trend line, and to do that, we haven't done a trend line in a while. We're going to click on our data, add chart element, and add a trend line and then more trend line options. We're going to scroll down and make sure we set intercept to 0 and display equation on chart. And I've already done that right here too. And I've also changed the name of it. Usually it just says y is equal to those values, and then I just added a little bit of into that box. So my trend line shows that it's really close to a 1-to-1 relationship based on the data. Now, if you can see, there is noise in the data, and when you take the second derivative, there's a lot more noise, especially when the distance between time intervals is really small. And so I show nearly a 1-to-1 relationship in this set of data. That's it today for the data processing. One little tip before we finish for the day. I recommend you type your figure captions and annotations right next to your graphs. It'll be really easy to copy and paste those over to Word. And also, when you hand them in as the draft Excel and in Diary, I can look over those annotations and tell you if you need more. And that's it for today. Thanks for watching.